Okay, guys, I'm going to go over RATEY real quick. Graphing rational functions. This is yesterday's notes as well as today's. Happy Halloween, by the way. Okay, here we go. You have to factor top and bottom before you can graph these functions. And if you have something that crosses out, remember if you have common factors, that tells you where the hole in the graph is. Okay. R is for the root, or roots, if you set the numerator equal to 0 and solve. A is for vertical asymptotes. Set the denominator equal to 0 and solve. T is for tangency. So again, you look at the numerator. So if I have x minus 2 squared, I know that I have a root at 2, and then that even multiplicity up there tells me that I'm going to have tangency at 2. So there's my root, and it's going to bounce. It could bounce below, or it could bounce above. The togetherness is on the bottom. If you look at the denominator, and the same concept. Here I know that I have a vertical asymptote at 3. But if I have even multiplicity, then that tells me that I have togetherness at that vertical asymptote. So the graph may be up here, coming together, the volcano effect. See, there it is. Or it may be down here. The end behavior, the Bobbio Botno eats DC. Remember, we're looking at the degrees on the top and the bottom of the rational. If it's bigger on bottom, then y equals 0. If it's bigger on top, then it has no horizontal asymptote, and you have to divide to find the slant. And if exponents are the same, so it's equal, then you divide leading coefficients. And then the last one, the y, is you find the y-intercept. So I'm going to flip this over, and I'm going to go through one of these with you. Let's do number 5 here. It's already factored out for me, so I have nothing to cross out, so there's no holes in my graph. I have a root at -1. I have a root at 2. My vertical asymptotes, I look at the denominator, so I have a vertical asymptote at -3 and +4. On the top, my multiplicity here is 1, here it's 2, it's an even exponent there, so that means that I have tangency at 2, 0, so I'm going to bounce. And then on the bottom, I have even multiplicity at -3, so that means at x equals -3, I'm going to come together. My end behavior, this is a cubic on top, a cubic on bottom. My leading coefficient here is 1, my leading coefficient here is 1, and I have that little negative out front, so it's -1/1, or y equals -1. And then lastly, when I plug in 0 for x, I get -1 times 4 over 9 times -4. So I get a -4 over -36, so a +1/9. Okay, so let's look at the graph. I have a root at -1. I have a root at 2. I have a vertical asymptote at -3. I have a vertical asymptote at 4. I have a horizontal asymptote at -1. And lastly, I have a y-intercept right there at 1/9. So I have 3 coordinates right here that give me a good shape of the graph. From this 2, it's either going to go up or it's going to go down. I've found that I have tangency at 2, so it has to bounce and go up. At -1, it's either going to go up or down and approach that vertical asymptote. I do not have tangency at -1, so it's going to pass through and go down. Notice I crossed the horizontal asymptote there, but that's perfectly fine. Nothing wrong with that. I know that it does not return and go up there because I do not have any more roots. There's no more roots right there on the right side of -3. So that's what the inside looks like. Now from here it's pretty simple. To the right of +4, it's either going to be up here or it's going to be down here. Well, I do not have togetherness at 4, so this graph has to be here. I also do not have any more roots, so the graph cannot be up there. And then at -3, I do have togetherness, so this graph has to be down here. It has to come together with that inside part of the graph. So there's your final answer. That's what it would look like. So, hope this helps. Feel free to email me if you have any questions or come see me in tutorials. Thanks.